Hello everyone, welcome back to my YouTube channel Learn with Sumi. Let's go little deeper into the dot product and look at some cool properties that make it so powerful. Okay, now we have two vectors. Okay, consider two vectors in space, somewhere in space. Vector A and vector B having some angle theta. Okay, vector A and vector B, some angle theta. So let's first see the formula. A dot B, which is mod A mod B cos theta, right? So this means the dot product tells us how much two vectors point in the same direction. So that how much two vectors point in the same direction. Okay, this is done. So if they are exactly in the same direction, consider if they are exactly in the same direction, A and B, then the theta is equals to 0, correct? And cos 0 is what? 1. That is going to be, the maximum dot product. That is going to be the maximum dot product if it is in the same direction. If two vectors are in the same direction, cos 0 is 1, so 1 mod A mod B, that is going to be the maximum of the dot product. Now let's talk about perpendicular vector. Okay, this is vector A and this is vector B, right? And perpendicular means the theta is 90 degrees, correct? If vectors are perpendicular, that is at 90 degrees, then what? Then cos 90 is what? 0. This means the dot product is the minimum, or A dot B is equals to 0. Correct? So the dot product is a quick test for perpendicular vectors. Now we have one more thing. Okay, A dot B equals to B dot A. I'll show you how. This is a commutative. So that the dot product is commutative in property, commutative in nature, is commutative. Okay, that is A dot B is equals to B dot A, which means just like 2 into 3 is equals to 3 into 2. So doesn't matter like which order, it is the same. Okay, then dot product using, we have one more dot product using unit vectors. Okay, unit vectors are what? I'll make one more video on unit vectors so that you can understand it easily. I, j, k. So these are the unit vectors I, j, k. So presenter. Now let's break it down using I, j, k unit vectors. Okay, so if I do I into I equals to, they are j into j equals to k into k equals to 1. Okay, because they are pointing in the same direction, because they are pointing in the same direction. Okay, now we have I into j equals to j into k equals to k into I equals to 0, because they are pointing in the opposite direction. They are pointing in perpendicular, not opposite, but they're pointing perpendicular. Okay, they are perpendicular to each other. Ij is, they are perpendicular, they are perpendicular, and they are perpendicular. So actually this helps us when we are calculating with some components. No problem. Now we have like dot product in matrix form. Okay, in the matrix form. So here's how you calculate the dot product using its components. So if A equals to A1I plus A2J plus A3K, and vector B is equals to B1I plus B2J plus B3K, then A dot B equals to A1 B1 plus BA2 B2 plus A3 B3. Okay, so just multiply the matching components, okay, and then add them up. It's super easy, right? Now, okay, this is the bonus tip what I'm going to give, vector projection here. So want to find how much of like one vector points in the direction of another. One vector, how much it is pointing in the direction of another. So use this formula, it is simple. So component of A along B equals to A dot B divided by mod B. So this is going to give us the scalar that tells how much A shadows onto the B. Okay, and that's the magic of dot product. It's simple, powerful, and super useful in engineering, physics, and computer graphics. So if you'd like this, don't forget to like, share, and subscribe for more of these type of videos. Okay.